We'll start our journey through the voice signaling protocols, the protocols that make the voice over IP world happen. By talking about the one that Cisco helped create, it is MGCP, the Media Gateway Control Protocol. This one is pretty popular in the Cisco realm, especially if you're using a call manager device. It's kind of the core of everything in MGCP. We're going to look at where MGCP is, or what MGCP is. What is MGCP? Why would I use it? What are the versions of it that are out there? What makes this different from the other signaling protocols like SIP and H323? I'll then walk through the reasons to use MGCP, like why would I choose this over some of the other protocols for my T1 or FXS ports on my gateways. We'll then look at the messages, the control messages that happen between the gateway and the call manager, and then walk through a call flow, step by step, as if somebody was picking up the phone and making a call, how MGCP handles and controls that call flow from start to finish. The Media Gateway Control Protocol, or MGCP, is a voice signaling protocol whose purpose is to set up calls. Its goal is to make voice communication happen. It doesn't actually send the audio. That's the goal of Real-Time Transport Protocol, or RTP. MGCP sets it all up and gets it going. Now, this is the first of the three protocols, MGCP, SIP, and H323, that we're going to talk about. And it is the only one that is a server-client voice signaling protocol. And it separates the call control and the media translation. So what that means is that the call control is handled by the call agent. Like, let's say that these routers are MGCP devices. This guy is going to be completely controlled by the call agent. So if you've got a phone attached to this router and somebody picks it up on an FXS port, as soon as they do that, the router runs to the call manager and says, call manager, what do I do? Somebody picked up the phone, what do I do? And the call manager goes, whoa, okay, settle down, little gateway. Just go ahead and play some dial tone. And the gateway goes, and that's when you hear it. And you hit the 5 button on your keypad, and the router runs to the call agent going, what do I do? They hit the 5, and the call agent goes, it's okay, just breathe easy, stop the dial tone, and play a beep. And the router goes, beep. And so every single thing, it's like a dumb terminal. Every single thing that deals with the call control is sent and handled by the call agent. The beauty of that is everything's centralized with MGCP. There's very little configuration that exists on each one of these, and it allows you to centralize your dial plan for your organization. Rather than having to create a dial plan on this router and this router like you do with H323, you can just create it in the call manager cluster, and everything is handled that way. Now, the media translation, and what that means is the actual audio translation, is handled by the gateway itself. So as somebody speaks words into that phone, the phone is going to convert and change that audio into packets and send it on its way. The call agent doesn't do that, and that's good because it's distributing the actual workload to the router. So the router's DSP resources are doing something rather than just throwing it all on the call agent. Now, there's currently 2 versions of MGCP that's out there, and most versions of call managers support version 0.1, and that's the default version that all Cisco routers run. Now, it became an industry standard and standardized in RFC 3435 as version 1.0. Not too much difference between these guys. It's just one is an industry standard and one was pretty much a Cisco design in version 0.1. So you're not really getting one major benefit by moving to 1.0 or anything like that. And just about everything that you run in the call manager world is 0.1. So before we get into the technical depth of MGCP, let's talk about why you would want to use this protocol. I mean, why would you choose it over H323 and SIP? Well, the first, and I would say the biggest reason why, is you want centralized management. By using MGCP, as I was just mentioning, all of your gateways report to your centralized call manager cluster. With H323, and in many cases SIP, all of your gateways need their own dial plan. So you have to go on there and configure a localized dial plan to have any kind of dialing functionality. With MGCP, all of the routers can report to your centralized dial plan database. So you can just create the dial plan one time, centralize it, and all of these devices will use that dial plan without you having to input a configuration in each one of those. Now, I should also mention, in the same breath of this reasons why you would want to use MGPC, centralized management is a big benefit, but if they lose their link to the call manager cluster, then you need to have some kind of backup dial plan on the router. And some people will use kind of a combo configuration where they'll use half H323 and half MGCP in order to make this operation work. And let me give you a better picture of this. Maybe you've got your centralized cluster right here, and that connects to a router, and you got your IP phones at your central site and all that's happening. And then you got this remote site, which is a centralized configuration. You got some phones over here doing their things. They're ringing, and they get their dial tone from the centralized call manager cluster. Well, if this gateway at the remote site, let me draw our site here. The remote site is MGCP controlled. If this WAN link fails, then it loses all intelligence. So it's stuck. It doesn't have any backup dial plan built in. Cisco has a catchy term called MGCP survivability, which means that you have a backup dial plan. What all survivability really is a system that says if you lose your connection to the call manager cluster, revert over to an H323 configuration. So for ease of configuration, you actually lose some of that when you need to recreate that dial plan anyway. Does that make sense on the remote gateway? For survivability purposes, so they can end up routing calls to the PSTN. So centralized management is a big benefit, but it does not mean you will not have to come up with a dial plan on some of your gateways for survivability purposes. Second reason you would use MGCP is you want simple or unintelligent gateway configuration, aka service providers. Now, this doesn't have to be a service provider environment, but there's a lot of service providers nowadays offering managed voice over IP services. So here's the service provider, right? SP. They go to clients, maybe a small business of 20 phones, and they say, hey, you know what? We're going to manage your data connection to the internet, and you're using managed services through us. And you know what? For $300 a month, or whatever cost they come up with, we will manage all of your voice system as well. Pretty sweet deal, huh? So this little business over here gets all their phones managed from this service provider, and the service provider controls that gateway using a centralized cluster. If the user were to break into that gateway, they wouldn't see anything. It's MGCP. It's just going to the IP address of the call manager cluster at the service provider to get its intelligence. So they could start doing that for many different customers and just use a centralized dial plan for each one of them. It's pretty awesome. The last one, oh man, that last one could be talked about for quite some time. I'm going to give you the overview of it right now, and when we get into, let's see, what will that be? That'll be when we talk about PBX connections. We'll talk more about QSIG. But we'll use MGCP for what's known as backhaul QSIG configurations. Here's what that means. You've got a router, and you want that router to connect via a T1 line to a PBX system. Now, there's many reasons why you might do this, and we'll talk about those when we get into the PBX nugget and later on in this series. But one of them might be that maybe your company is slowly migrating to voice over IP. So you got all these digital phones happening on the PBX over here, and you're slowly bringing up a voice over IP network. This is my little switch over here, and you're slowly bringing up a voice over IP network on this side, and you want to be able to bridge voice over IP to the PBX system so that these phones can call these phones and vice versa. Well, in order to make that happen, you need to link up with the PBX system using, say, a T1 line or something like that. And a QSIG or MGCP backhaul means that T1 line and all of its characteristics are not managed by the router, but instead managed by the Cisco Call Manager cluster. Now, the benefit that gives you is you start getting some features between them. QSIG stands for Q signaling. It's not a fancy acronym. It's just Q signaling. Nobody knows what Q really stands for. It's a generic signaling standard that PBX vendors came up with so that their PBXs could interoperate. I mean, think of the PBX world, right? You're in a proprietary lock. If you buy a Lucent PBX system over here, and you got Lucent phones and Lucent cards, it's only meant to connect to another. Let's say you're using a tie line, over the PSTN to connect these two PBX systems. It's only meant to really connect to another Lucent PBX. But maybe two companies merge, and you've got over here Nabisco, and over here you've got your Keebler Elves, and you're merging these two companies together. And the Keebler organization used a Nortel PBX, and you've got this Lucent one. Well, QSIG was the language of love that they came up with between these PBX systems. It's kind of like TCP/IP, right? TCP/IP lets all kinds of different vendors' equipment talk, like Dell and IBM and Cisco. They can all talk because they use a standard protocol. And PBXs use QSIG for that kind of thing. It allows some of the features like hold, like transfer, like message waiting indicators, and all that kind of stuff to happen between these PBX systems, even though they're from different vendors. So if you have a QSIG environment, or you want Q signaling, the only way that you can support that is using a system known as MGCP backhaul. What that means, and the reason it has this name, is the router handles all layer 2 communication over that T1 line, or it's actually a PRI connection between those two. So all layer 2 communication is handled by the router, and all layer 3 communication, which is all the signaling, the Q signaling, is handled by the call manager. That's the backhaul piece. So when the PBX says, hey, turn on your message waiting indicator for that phone over here, because they have a voicemail, maybe the PBX is handling voicemail services as well, then what happens is the router says, okay, I don't understand message waiting, but I'll send that to the call manager. And the call manager goes, oh yeah, I got it, no problem. Light, and the light comes on the phone. So that allows you to kind of bridge the two worlds of PBX and routers and voice over IP transparently. It's pretty awesome. Only way to make that happen is MGCP. So that's one of those features where it's like, you gotta use MGCP for it. So here's the architecture of how it all happens. You've got this router over on the left-hand side of this diagram that you would like to control via MGCP. Got an FXS port to an analog phone, you've got a T1 line out to the PSTN, then you've got your IP link back to the call manager. What will happen when you configure this router, because it does still, even though it's minimal, it does still take some configuration for MGCP, the router will go out and actively establish the TCP session with the call manager. Now, I want to make sure that you catch that this is initiated by the router. The call manager will have an entry in its database for the router. It actually uses the router's name. So you might name this router, RTRA. And that will go over to the call manager and say, hey, I'm RTRA. The call manager looks at its database and goes, I know you. It needs to have a configuration for it, obviously. And it says, Router A, I've got you configured for an FXS port and a T1 line. So you will have to go into this call manager. I'll show you this when we get to the config, and set it up to recognize this router and all of the voice ports on this router. Call manager will then audit, this is actually the type of MGCP message it sends, audit endpoint, that's what it stands for, AUEP, and registers, that's RQNT, that's a RQNT, request notification. Thank you. You'll see. We'll see all these messages on the next slide. But the RQNT is a request notification to register that configured endpoint. Now notice I have configured endpoint. On this router, you will have to go in here and set up each endpoint to be handled by the call manager. The call manager doesn't just come in like like the Matrix Part 2 where Agent Smith starts taking over people's body. It doesn't do that. It doesn't just come over and it's like, whoa, and it owns that router. You have to go into that router and you say, okay, this endpoint right here will register with the call manager. This endpoint right here will register with the call manager. You don't have to do that. You could say maybe the FXS port registers with the call manager and the T1 line might be handled by H323. You can have like these routers that use different protocols. They're kind of split into different pieces. You could use all three. I could have that port MGCP, this one H323, this one controlled by SIP. It's totally up to you. So it's strange to do it that way, but you can. So the endpoints that are configured for MGCP will come to the call manager and say, hey, we're ready to go. The call manager will send request notification to those endpoints saying, when these things happen, let me know. That's what this little request notification message is. Like for the FXS port, when that phone goes off hook, let me know. When that phone dials a number, let me know. Send me a message letting me know about this request so I can tell you what to do with it. So the call manager now controls that endpoint using a series of MGCP commands. These are those MGCP messages. These are the lifeblood of MGCP. If during a call, like somebody were to pick up this FXS port and make a call, you were to open Ethereal and start sniffing packets, you would see these messages coming through inside of those packets. For example, when this phone makes a call to another phone, and the next slide is actually a full call flow where we can work through each one of these. But to give you an example, when this phone makes a call, it goes to the call manager, says, hey, I want to make this call. The call manager looks up in the database where it's going and then sends a create connection message, CRCX. We're going to create an RTP session between these endpoints. The notification request message is what we just mentioned on the previous slide. When you register this gateway with the call manager and it's saying, hey, I've got these endpoints, it will the call manager will send notification requests saying, please let me know when that phone goes off hook or when digits are dials. Those are request notification messages or notification requests where it's saying when these events happen, notify me. And there's even full, and I won't get into it here, we don't need to get that deep, but there are full event packages for MGCP. Like if you go to Cisco's website and just type in MGCP events, you will see this giant list of packages saying for the home gateway, these kind of events are expected. For a small business gateway, I'd expect these kind of events, and remote office gateways. All these different packages of events of things that are expected and can happen and can be notified. The call manager can be notified of those. And you can see we've even got a notification. That's what happens. When you pick up that handset, a notify, NTFY message comes out from the router, goes to the call manager and says, hey, something happened. What do I do? You've got, delete connection when you're done with the call, restart and process when it's rebooting the gateway or reinitializing the configuration, modify connection, like if somebody presses the hold button, the connection is put on hold, we need to modify it, stop the RTP stream, and all those kinds of messages control that gateway from the call manager cluster. Okay, last thing I want to talk about in this opening nugget on MGCP is just the call flow. This is really useful to catch for troubleshooting purposes and really understanding these messages that are going back and forth between the routers. So here's the scenario. We've got two routers. We'll call this guy local. This is our local router, and a remote router. Both of these routers are controlled by the Cisco Call Manager cluster down here, so that's going to be where the messages are sent and received from. Now, for sake of this example, we'll say that everything has registered. The ports, the FXS ports, are under MGCP control, so we'll start off right here in step one. The local phone, which is this guy right here on the left, goes off hook, so somebody wants to make a call. As soon as that happens, the router sends a notify message to the call manager saying an event has occurred. I have an off-hook event, and that's one of those events that are defined in the MGCP standard. Now, call manager immediately replies and like, whoa, okay, let me reply to you with an RQNT, a request notification message saying, here's what I want you to do. I want you to play dial tone. So, we've got the dial tone going on the phone, and I want you to collect digits. There's a collect digits message that is sent. Now remember I mentioned that the router, when somebody dials a 5, is like, oh, call manager, somebody dialed a 5, what do I do? The call manager says, oh, okay, that's okay, play a beep, all that kind of thing. Well, when Cisco designed MGCP, they said, man, that's gonna be overwhelming. I mean, think about it. If you've got 1, 2, 5, 600 routers that are all processing calls and digits are going back and forth to the call manager is going to be like, whoa, too many digits, I can't handle it. So what they did was they enhanced MGCP. When a gateway registers with the call manager sends a copy of the dial plan. The whole dial plan is sent to that gateway. So the gateway now can understand and process at least the dial digits. Meaning, if somebody's dialing a number, you know how when you dial, well, maybe you don't know. When you're dialing on a phone, on a PBX system, or on Call Manager, if you start misdialing, like let's say you've got 1,000 extensions inside, maybe 1,000 through 1,100 are internal extensions. You dial a 1, you hear nothing. It's silence. It's waiting for the next digits, and then you dial a 5. Well, if there's no 1, 5 extensions, the router or the call manager will say, there's no use in collecting more digits. Meaning, I'm not going to wait for you to finish dialing this number that doesn't really exist. As soon as you dial something that's not in my dial plan, I'm going to immediately play a reorder tone, like sorry, that's a bad number. So the MGCP gateway can do the same thing. When it gets the dial plan, it's going to know when somebody starts going off in the wrong direction and be able to send a busy signal if they dial incorrectly. So it's processing. This guy's making a call, dialing, we'll say this device over here on the other side. We'll say this is extension 2000. So he dials 2000, the phone dials the digits, and once he's done dialing, the router realizes that's a valid number, so then it passes a notify message to the call manager saying, hey, he dialed 2000. What do I do with that? Well, the call manager is going to reply. He's going to send back a message saying, okay, you need to create a connection, CRCX. You're going to create a connection over here to this remote router, and it passes the information for the remote router and says, hey, this is the remote router information, and at the same time sends a message over here to the remote router saying, hey, you need to create a connection as well. It's coming from this local router. I've got an incoming call for you. So both of these, you can see the create connection is sent. Both of these routers send back an ACK message saying, got it. I will create a connection. I'm ready to go. ACK, ACK. So as soon as they do that, the call manager is going to send ringback and ringing requested messages to the local and remote routers. These are, again, these request notification messages. One of them to the local router says, hey, you need to start playing the ring signal. When you're on the phone and you hear the ring, that's the best impression I can do. You got to go with that. And then over here, he's sending the play, make that phone ring message. So the phone over here is ring, it's ringing on the handset and so on. So ringback and ringing are requested using the request notification. This RQNT message is used anytime it wants to tell the router to do something. Like, I'm sending you a message, and in between here, there's actually a modify connection message, MDCX. In between 3 and 4, it's just one message saying, hey, modify it, play that ring or ring back tone. The request notification message is saying, I'm telling you to play this, let me know when XYZ happens. That's why they call it request notification. It wants to be notified when some event occurs. So we're at the point now where we have a remote phone ringing over here on the left-hand side, playing ringtone for the person that's sitting at that desk, and this phone over here is playing the ringback signal in the handset. So the local caller knows that the remote side is ringing. So as soon as the remote phone goes off hook, the remote gateway sends a notify message to the call manager saying, call manager, somebody has lifted the handset. Now, as soon as that happens, the call manager receives the notify and sends a modify connection message to the local guy, MDCX, saying, hey, you need to start your two-way communication. Start the audio stream with the remote gateway. Now, at this point, the call manager steps out of the scene, meaning the gateways have stopped ringing. He sent the notify saying, somebody's picked up. The phone has stopped ringing. That happens within the MGCP gateway to stop the ring. He sends the modify connection saying, stop playing the ring back, the brrr, on the phone, and start the RTP communication. That then goes router to router. The RTP does not flow between the gateway and the call manager. Otherwise, you've got a point of failure. If the call manager ever fails during a call, all the audio for those calls would be lost because it was flowing through that, and it would also cause more overhead. So RTP is flowing between these two routers, and the call manager is just sitting on the sidelines watching, saying, okay, we've got an active connection, that's good. It will do nothing more until the call is disconnected. Now let's say this local guy is like, okay, see you on Friday, thanks Bob, click, hangs up the handset. As soon as that happens, the gateway says, I've seen a change. The phone has gone on hook. Notify message to the local call manager. The call manager will then say, okay, I've received that. I'm going to send a disconnect message. DLCX, delete connection. Disconnect the connection on both the local and the remote router. They both receive that. Send an acknowledgement back saying, ACK, call is dead. and the call goes into a disconnected state. And that's where you have the bandwidth stop being sent, the call is terminated between the routers. Do you see how MGCP can really give you that mainframe kind of feel? Like every character you're typing on that mainframe is sent to the call agent and saying, okay, what do I do with that? So that's the general view of MGCP. And that's where I'd like to end this part 1 of understanding and implementing MGCP. Part 2, we'll get into the actual implementation. So we talked about MGCP defined. It is the only true server-client protocol that's out there where every action is reported immediately to the call agent, and it divides that call processing. The router handles the processing of the call itself and the call media, whereas the call agent handles all the signaling. The reasons to use MGCP, we saw, was primarily focused on centralizing all of that functionality. You get that in a great service provider environment. You get that in a enterprise organization where you just want a centralized dial plan without having to re-replicate that on all your different devices. We also saw that MGCP backhaul configurations using QSIC, I'll talk more about that in the next nugget too, is one where you have to use MGCP because you need the call manager behind the scenes to process those signaling messages sent from the PBX using QSIC. We then saw the MGCP messages, the 8 primary messages that MGCP uses to control the gateway, and then saw those messages in action by walking through a call flow. So I hope this has been informative for you, and I'd like to thank you for viewing.